Still out of her interview for head coach. You fell asleep, didn't you? Okay, just when you thought it was safe to go back in the water, you've gone through everything that you're going through in your projects, you've got everything running. Then you get to turn around and you get to look at it. Monitoring is really serious because you've got such a high velocity of data. It's short for model performance monitoring, obviously, after deployment. And what do you got to do? You got to observe, measure, and analyze performance and behavior in these environments. Who does that? You guys certainly play a role, everybody. Technical people are looking for the metrics on the model. You guys are looking for KPIs. The analysts are right in there between them. Everybody monitors. Probably the first thing that'll show up is the model metrics, but you get to play a role. So you get to do this first. The technical people will take care of this. And of course, there are all sorts of performance metrics depending on what kind of model you use, which you guys are up on very quickly. So current performance against baseline metrics that you've established during development and testing as KPIs. If you're looking for degradation, that comes in a lot of different ways, and we'll talk about. And again, this all goes to how well that model generalizes. How do your predictions play in the real world? Every single case, every single time, every deployment, you're going to get edge cases, without a doubt. Edge cases are going to probably crop up with business professionals first. It could be a disaster in metrics, but usually it's a case that just doesn't fit what you planned for. Can you plan for all these? No. And then you're looking for timeliness and relevance, obviously. So here we go. You're going to get drift. It's going to happen. Conditions change. You're not working in a vacuum. You change regimes in Washington. You get new laws passed, new regulations, international geopolitics and economics, everything that goes on. The Fed cuts interest rate by a quarter point, so on and so forth. So you get all of this, and if it drift, generally refers to degradation. Then you've got these different kinds. This is what you've got here: model drift, degradation, concept drift, data drift, prediction drift, and performance drift. Then, last but not least, changes in the operating environment. Now, this will happen regardless of what you do. So concept drift, this is where you've got the change in the underlying relationship. Okay, you've got your input features, you've got some output variable that you're trying to predict, and the underlying relationship actually changes. We'll be coming back to that. Data drift, obviously, is you've got some, we touched on this briefly. All of a sudden, you start to get a new data set all by itself, and you're trying to figure out, am I looking at outliers? Should I keep them? By the way, you don't delete outliers. You always keep them off to one side. Do I incorporate them with the rest of the data? Do I know what's going on? This is almost the underlying drift that you'll see or change lead to concept drift and performance drift. Now, you've got your pipeline set up. You've got all sorts of data streams coming in, for example, that feed the transaction processing systems, point of sale, clickstream, sensor data, social data, and so forth. And so you've got to check your pipelines. The good news is technical people handle that. They'll go in, take a look at the data drift. They'll feed that back to the analyst and you guys. Now, prediction drift, this blows up when you've got the predictions are changing. This is going to show up in metrics. if the input data, if the data distribution looks fine, you're going to check it up here, and the statistical properties get off, you'll know it. And so that is, I've left changes in the operating environment off for the simple reason that it's hard to predict those. So obviously, you're going to track performance metrics. This is technical. Monitor changes input data, that's technical. Can you do this on the fly? Sure. What do? You sample. Then you analyze prediction patterns. Again, technical. And you can always have holdout data sets. This is great unless you've got a monster model like some of these large language models. And we're kind of running out of data on those. So that's a problem. But this is great. This doesn't filter to you after it's been examined by the technical team. By the way, they will be asking you questions about that. Not about these four things, but about the results. Okay, operational monitoring, how it functions in the environment. Clearly, these are technical considerations. Latency, time lag. Again, we want sub-millisecond response rates for like predicting credit card fraud or fraudulent transactions. Throughput, okay, we don't have anything that we have to worry about with this here, except for anomaly detection. This is very straightforward. These are technical metrics that your technical professionals will look at. When they get to an anomaly, though, that could be statistical. Chances are the data's changed. Edge case comes in. You guys are the edge case people. Naturally, we look at ethical compliance. That's on you. Bias and fairness, that's on you. Compliance monitoring, of course. This is just everybody does. This is probably about as ticklish as you can get. When you get in this space right here, you're going to have lawyers in the room with you. And you should, by the way, they'll make you feel better having them in there, because you can always blame them. Just kidding. Security monitoring, naturally, business impact, that's on you. Security monitoring is technical. All this goes on all the time. Now, you've got monitoring, which you're going to do all those things, and it's going to lead you over into maintenance. So you're going to have to change things. So monitoring first, then maintenance. By the way, this is one of those virtuous loops. Monitoring leads to maintenance. You make the necessary changes. It feeds back in the system, and you start monitoring again. So what do? You manage, update, and optimize the models. Okay, no problem. Well, by the way, who does monitoring and maintenance?
The analyst.
Well, you're the end result. The technical people are going to do this. Okay. Look, you guys have jobs. You're business professionals. You're not technical people. You got other things to do. If they put you like you're going to monitor an ongoing neural network, what are you going to do the rest of your day? Okay. So, monitoring and maintenance. Monitoring gives you insights to trigger maintenance. Straightforward. It continues after your maintenance activities. It never stops, okay? Reactive maintenance, that's going to respond to issues that are already detected. This is exactly like maintaining your car. Okay, there's not any difference here. If you're, okay, we all monitor our gas gauges. If the little gas tank lights up, that means you're getting really low. Okay, that's maintenance. You got to go fill the car. That's all you're doing here. So monitoring does reactively. Monitoring leads to reactive maintenance. It also will let you do proactive maintenance if you pick up the issues before they significantly impact model performance. Now, that's a lot trickier. If you're doing a large neural network, billions of parameters, and you're trying to do proactive maintenance, you're gonna have to have that on the fly. And so that's strictly a technical issue. Now, here are your strategies. You can update the model, then you're gonna retrain it. Why? I've got to have new data. I can tune or optimize what I have. I can get into the data pipeline, do maintenance there, or I can get down in the compute, the infrastructure maintenance. You know what? That's a tough question for you guys. You're not going to necessarily be doing this because this is technical. You're sure not going to be doing infrastructure. Data pipeline, no. Tuning and optimizing, maybe. But updating and retraining, you're going to have to make a decision if you have to do that, if things are bad enough to update the model itself. Now, you've got to figure out when and how to update or retrain these models. So you're going to look for significant drops. You've got three strategies as usual: schedule, reactive, and proactive. The most expensive is scheduled because you're going to do it regularly. Also, this is fun because you got a scheduled maintenance coming up. Nothing's going wrong. You're going to do it anyway. Reactive, something's gone wrong. And proactive, this would be great to reduce costs, but that gets a lot trickier. Okay, regularly planned, okay? Every 3,000 miles, change oil in your car. Can lead to extra expenses because maybe unnecessary. All right, here's detected issues, fix it. So proactive, you anticipate, and you'd love to stay ahead of the situation. How you update these things, once you decide to update a model, you can do incrementally. Notice you update the model with new data as it becomes available. What's interesting is, what does this mean here? It means you're always doing incremental updates because you've got new data coming in every second. Or you could do full retraining. What does this mean? It means your model drift is so bad, I can't use the original model incrementally, so I'm going to have to rebuild it. This is basically, you're going to have to decide you're going to keep running the old system while you rebuild it for the new system, or you're going to pull it offline. It all depends on what you're using. If you're running the UPS model that we studied, you're not going to pull it offline. Okay, it's going to be trained incrementally all the time unless something really goes bad. So I'm looking at data patterns here and model architecture, et cetera. Anything that's just totally significant enough to come up with a new model. New model typically means new features. Okay, you can tune hyperparameters. You've seen us how we've done that to optimize depth of trees or how many random forests you want to generate. Feature engineering, we've talked about that, and we've done some of that. Ensemble methods like random forest. You can tune all these various things. Now, the good news here is technical people will do that. Okay, data pipeline, data quality. You know what? This comes down to that data lineage we were talking about. Where's it come from? Who's touched it? What does the quality look like? There are data engineers in your technical professionals. Okay, versioning. All right. You can have different iterations of a model throughout its life cycle. You're going to have to log all those changes. And you say, who's handling all this? The technical people are handling it. They're going to document. They're going to document their changes, and they're going to show you the versions. Again, you'll have the final authority on that. So when you go through just monitoring and maintenance, it comes down to everything's going fine. The technical people have their hands on it, and you have the rare privilege of signing off on it, which is a good thing. Okay. We got a lot of work going on autonomous cars. This particular company's got this image recognition system, and then it has to react to everything that you can imagine. Road signs, pedestrians, and so forth. Not only that, it has to do it in a sphere, 360 degrees, three-dimensional, and It's all image recognition, a lot of processing, and that is the key to its decision-making process. That's an interesting problem. All right, there are your metrics. Accuracy would mean the car gets back to the barn in one piece, doesn't hit anything or anybody. Has to identify all that kind of stuff. Notice, this gets really interesting. I want to dump false positives. If you're an autonomous car, what's false positive?
Where it thinks someone's there, but no one's actually there.
Yeah, it could hallucinate a person, could misread a sign, traffic light. In there, and you're looking at accuracy, precision, recall, all at the same time. Doesn't do a bit of good if that car identifies somebody walking on the sidewalk. With any luck, your car is not driving on the sidewalk. Okay, so you don't want irrelevance. But if you have a jaywalker, you better pick them up. That gets to be real life, if you will. And it's in real time. You've got all these baseline metrics you've already established. So then they start comparing to the baseline. And this particular case, in this company, when they were developing it, the system achieved very high accuracy. Now notice, when you're training these things, you do them on the road and you do sims. You're in the simulator. So it got high accuracy and it picked pedestrians up really nicely under clear sunny conditions. What does that mean? If you got a thunderstorm, are we in trouble? You really don't want to shut down your autonomous car in a rainstorm. So people are starting to think through this and they say, okay, so this baseline metric serves as a performance level. Keep in mind clear sunny conditions, which I was real surprised. Okay, the system began to decrease, especially in snowy conditions. Actually, all of our performance decreases in snowy conditions. Okay, we get away with it. What do y'all do in snowy conditions? Well, down in the south, if you have 1/8 of an inch of snow, everybody parks their car. The rest of the country laughs at us. Y'all know what it's like driving in snow around here. It's like bumping cars. Okay, but you slow down and you give it that number. Well, that's what they'll do too. But notice, the system being in the car, its performance accuracy decreased. They picked that up as model drift, that's good. Changes in the environment that are edge cases. They're not well representative initial training data. All right, so first thing they encountered is a snow-covered traffic sign. Now, that's really interesting because would you guys have thought about that? Or how about just outside Harpersville, Alabama?
A traffic sign, are you saying like where someone will put up like workers present, that sort of thing?
No,
or
I'm
like,
talking about a stop sign that has snow on the top half of it. Hadn't melted off.
aren't most of those in GPSs anyway?
Oh, I don't know. I don't know. This edge case, it sure wasn't. But this particular case had a stop sign that, enabled the car to run it. So they're busy monitoring here. So what do they have to do? Well, let's don't forget fog. We might want to remember rain's probably a good idea. Water on the roads. And so they use sims to simulate these edge cases. And so I like this rural areas versus urban. But they had to make sure they handled the edge cases. By the way, this is what people do. If you're a developer in a system like this, a lot of you would be assigned to, a lot of us would be assigned to edge cases. And all you do is think up edge cases. Okay? We already talked about the ethics of a kid running out in front of you, but that's a severe one. So they've got to have their timeless and relevance. It's got to be within milliseconds. They've got to fix all this, braking, lane changing, and so forth. So they had to fit that into the system. And so it worked out that this is where we are now. What are we doing with our autonomous vehicles now? By the way, they do work. They're trying to simulate edge cases where you're dealing with humans. That's our problem. Think trucks, if you will. That's where we are first. Zillow is, as you guys know, real estate. They had a lot of model drift with their Zestimate algorithm and their iBuying program. It was trained on historical housing data. It didn't accurately predict home values during COVID. Unanticipated market conditions. We had record low interest, pandemic-driven migration, and it gave concept drift. This is totally a different concept than that original program was developed with. Remember, COVID was a finite set of months. Nobody saw it coming. Okay, so the home price appreciation accelerated beyond historical patterns. Consumer preferences shifted dramatically, all because of what was going on during COVID. Now, by the way, if the interest rates go record low, people tend to overbuy their homes. Okay. So the consequence is, November 21, Zillow shut down the program, laid off a fourth of their people, and took a $300 million inventory write-down. That was pretty severe. Zillow almost went under based on that. By the way, who'd predict what COVID would do? Nobody. And that's global. JP Morgan model drift because of their credit risk, and they evaluated, of course, historical payment. They used historical data. Now, what they got was data drift because of government interventions, stimulus payments, enhanced unemployment benefits, and so forth. Again, I think, okay. And then their relationships between income stability and credit risk became decoupled during COVID. So this is COVID again. We had 3 rounds of government stimulus payments. Unemployment benefits continued, and they had a change in financial behavior. Here's the consequences. They very quickly had to adjust their models. Now, if you're going into COVID and you're in there about, how long would it take here before you saw data drift? We came to school here, guys, in 2020. Yeah, we started spring semester 2020. Spring break, everybody went home and nobody came back. You guys were here, weren't you? Y'all weren't here. Y'all in high school? Were you 3 in high school too? Wow. Here with children. Well, let me tell you what the adults did. We were told, nobody's coming back after spring break. So congratulations. We all got to sit down in front of our screens with a camera that focused on our noses, because almost every faculty member at Auburn got too close to the screen. So all you got to do is watch their noses while they completed the semester. All the lectures for the whole semester. Okay, so we saw it within 3 months. Now, I wonder how long it took JP Morgan before they started that. I don't know. But notice at the end of 2020, what they did, they had to adjust their models, okay? At the end of the 2020 report, they did note their increase in model uncertainty and what they call management adjustments to compensate for model limitations. What that meant was their risk model blew up, and my guess is probably they missed a few dollars in there. We moved pretty quickly in academia. Walmart, they had concept drift in their forecasting, inventory forecasting. What they ran into was climate change. Walmart was the first company into New Orleans after Katrina because their supply chain is well connected and they revectored their trucks. So they got water into New Orleans first. But notice, this has got to be, unfortunately, a political football, but trust me, every company out there is now paying attention to climate change. And so Walmart's models, their machine learning models, calendar dates historical weather patterns. Well, that's perfectly fine. Did you see what happened in Jamaica with that latest hurricane? Okay, it strengthened. It had 185-mile-an-hour winds when it went there, so it's above Category 5. It's interesting, Jamaica had purchased, I want to say, $1.5 billion worth of insurance prior to this hurricane season because of the rapid intensification of these storms. So at least they were thinking ahead. So people are starting to pay attention. So, but notice when you get this, you're looking at historical weather patterns. We don't have those anymore. So to ask the people in North Carolina with Hurricane Helene, traditional weather patterns less reliable. Notice, less reliable predictors of consumer behavior. Look, this is a very complex sentence because we've got some strange weather going on, and it very much influences insurance. Well, tell me about the Florida housing market. Anybody familiar with it? How many insurance companies are left in Florida? They joined the NFL. Not for long. California and Florida are in deep trouble as far as number of insurance companies. Wildfires in California, atmospheric rivers in California, hurricanes in Florida. Now, has Florida had a hurricane this season? It has not. Not one drop. Welcome to the party. What about next year? Insurance rates have skyrocketed down there. So now you get impacts of consumer behavior. Okay, we're now getting zombie homes where people just take their keys, hand them to their lenders, and leave the state because they can't afford the insurance premiums. Okay, so you're talking about consumer behavior. Notice the timing of seasonal transitions. Y'all know the growing season's getting longer, moving northward. Tropical diseases are moving northward. So these seasonal transitions are being pushed later, and then regional variations in these seasonal patterns are increasing. This is an interesting look at a quick look at a very complex problem that Walmart any logistics company has to put in with their features. So they were getting increasing errors year over year. This is going to be ongoing. We've had a blitheringly easy year this year. Jamaica hadn't, but the rest of us have. Difference between calendar date and seasonal product demands fundamentally changed naturally. Now, notice what they're moving to, real-time weather data. They're also looking at regional climate patterns, and that rather than historical calendar based. So what we're looking at here is a map in between Walmart's logistics function, Amazon's too, UPS's too, FedEx's too, and real-time data. Where do you get real-time weather data?
Weather Channel.
I'd go to the Weather Channel. Where's the Weather Channel get its data?
Satellites.
NOAA satellites. Okay, Experian credit scoring. This is really interesting because they've had a lot of problems with this financial behavior of millennials and Gen Z. Different from Gen X, boomers, et cetera, et cetera. Notice what their models relied on in the past. Classic stuff, mortgage history, credit card utilization, long-term credit relationships, so forth. Notice younger consumers are delaying home ownership. Why?
Housing prices have gone up.
Housing prices skyrocketed, yes. Price of lumber skyrocketed, yes. But what's the main reason?
The Like it hasn't matched the growth of, or whatever the growth of
Why can't
starting
you guys buy
salaries
homes?
are. Huh?
Why can't you guys buy homes?
Don't have big enough credit.
No credit, correct?
And the,
Nobody lend to you, you don't have 20% down, number two, and you have student debt. Just because you're at Auburn does not mean we do not have $1.8 trillion in student debt in this country. Student debt's killing the home ownership. Okay, there's another reason for which I am currently involved. Boomers are staying in their homes. A much larger percentage of boomers want what we call age in place than move into what my dad called an old person's warehouse. Trust me, when you guys have to have that conversation with your parents, get ready for that. I mean, mother passed away years ago, and we had to do something with dad. Without mom, he didn't do too well. And he said, "You boys put me in a warehouse?" "Yes, sir." We don't do that anymore. Boomers are staying at home. Okay, so this is really getting to be interesting. But the main thing is, I think a lot of you are looking forward to home ownership. You got to mow your own grass now. My son figured that out. When he bought his first house, he called me up a few weeks later and he said, "I never knew there was this much yard work to do." But think about this. If you don't have this, suppose all of you could do that right now. We can't build homes fast enough. There aren't enough of them. Okay, so there's a lot of problems. Alternative methods, now this is cool. You guys use Venmo and PayPal. Y'all all use Venmo and other electronic methods of payment. Ask any boomer about that. So think about this. If you're the credit scoring people, you don't have those variables anymore because these have changed to what you guys are doing. And then credit invisible, okay, limited credit history, what came up, okay? And so now you've got to demonstrate financial responsibility through non-traditional means. Credit invisible just means you don't have a long credit history. And you could have no credit score at all, depending on, what age you are. But this is an interesting look at generational problems. I had not thought about it until I saw that. And they were absolutely misclassifying you guys as younger consumers, high risk. So look what you had to do. You got new models, rental payment history, utility payments. I had not thought about that. Y'all have utility in your name, or do your folks keep it in their name? Just curious, your name. And then subscription service consistency. Every one of you has subscriptions. And I had not thought about that. So those are predictors of credit worthiness. That's really interesting. What does this mean? New features. Can I leave the old features in there? No, it's going to drag you down. So you literally have to have, depending on your age, you have to have new features in the model. Now, Uber got into this because urban mobility patterns shifted with the adoption of ride sharing. Notice their initial models when they got cranked up, they were looking at, again, historical traffic data, which all of us would, distance, time of day. Okay. All right, here we go. They changed their own model because as people started taking the ride sharing, it changed the traffic density. Their function itself altered traffic patterns. Who knew? Traditional rush hour became less predictive. We do have some flexible work out there. I think that's kind of coming back to the standard. Are we getting returned to office?
or hybrid office,
Yeah,
it's like 3 days a week.
yeah, at the very least.
That's what
That's what you guys do. Can you pick 2 days like Thursday and Friday, or do you have to do Monday, Wednesday, and Friday?
it's usually by team, whatever the team wants. So like the team that I'm on does Monday, Wednesday, Friday, because most people do Tuesday, Wednesday, Thursday, like just of everyone. So there's less traffic on, at least on Fridays, but
Yeah.
Monday, I mean, the traffic's about the same.
Yeah, that's interesting. And then rush hour concepts, then the importance of special events. Look, I mean, it's great. Does Uber work around here on a football weekend? At all? We don't have enough Uber cars, do we? You know what it is? So they
Lyft is
just wait
cheaper.
forever, y'all just forget about it.
Say Lyft is cheaper too.
We'd have surge, wouldn't we? Surge pricing,
Yeah, but it's still always cheaper than the Uber. Like,
which is Lyft. Interesting. We have Lyft here? Yeah. Interesting. Which one do y'all use? Either one? Use both, whichever one gets to you first. And, sorry, Uber's here. So, that was interesting. Notice they had the grading accuracy in established markets. By established markets, their own rides were changing traffic. So they had to go to the change the features again. This is interesting. The density of active drivers and riders in an area, and they knew that they had changed the very system. That's interesting. So they GPSed everybody, which they did to start with, but they recognized they were changing this. Now, I've not noticed, I don't think we have enough Uber and Lyft here to change our traffic patterns. Notice what it did: increased vehicle miles traveled, add significant vehicle miles, deadheading, drivers trying to get to their passengers, replacing trips that would be taken by public transit. This is really interesting here because public transit, if you're going to look at autonomous vehicles, which Uber's desperate to do, I get a lot of people thinking, well, it'll really help public transit because we'll have autonomous buses. No, we won't. If you guys had an autonomous car coming to your house that you ordered up on your phone, why would you take an autonomous bus? It's going to be dirt cheap to take the autonomous car. My guess is public transit will get wiped out. But, especially buses. Look at the student buses going around town here. If you guys all had autonomous vehicles that would come to your apartment, pick you up and bring you right here to this school, why would you stand on the corner and wait? You wouldn't. Well, you compare prices very quickly. Okay. And then, of course, inducing new trips that wouldn't have occurred without the convenience of ride sharing. That's really interesting because Uber is still less expensive than owning a car. Take the driver out of Uber, the price goes down 60%. It's interesting. It changed congestion patterns. Naturally, they concentrate in popular areas and peak demand. Naturally, the surge, rush hour congestions, lower traffic periods. That's good. Downtown areas experience more circling and double parking. That's a forever problem until we get rid of that. Peak traffic, evening congestion is intensified. That's not good news. Rush hours broaden, and then, oh boy, as you know, airports have gotten crazy about that. You got to have the taxi lines, got to have the Uber, the ride-sharing lines, etc. That's fun to find. It has reduced public transit ridership. This is going to happen. And then transit availability and congestion levels. Now I'm talking about buses. I'm not. What do you think about subways? I wonder if AVs, autonomous taxis won't take subways out too. Subway's pretty quick, but I wonder. Now MARTA doesn't go where anybody wants to go. No, seriously, it's not their fault. It's expensive. They just have this X in Atlanta. What is it? Well, pretty much north, south, east, west. So once you get to where you're going, if you're not there, you got to take a bus. So I think we'd take MARTA out too.
It may depend on population size as well, because I think sometimes those subways accommodate for an area with a larger population.
Yeah, that's true. I'm just thinking with autonomous vehicles, if we ever get rid of the mix, if we ever get the humans out of the mix, we're going to have 80% fewer cars on the road because you'll be multitasking the vehicles. Just because it brings me over here in the morning doesn't mean it won't get one of you. So that card's just gonna be doing this all day. So I think we're gonna wipe out public transit. The cities will be happy. We're subsidizing all that. Okay, PayPal, their fraud detection, they had drift during the shift to e-commerce and digital payments. They trained with the average transaction amount, transaction frequency, and geographic distribution. Then new merchant categories that came in, and PayPal had to adjust their features. Notice their feature distribution shifted so dramatically that their false positives for fraud went up 30% before they had a chance to retrain them. Notice normal transaction behavior had fundamentally changed. They went to continuous monitoring, which every credit card company has now, so they could handle retraining. Inventory management, that's pretty straightforward, except for consumers that would, rather than come to the store, they shopped online. Their historical data, consistent patterns, product browsing correlated real strongly with purchase intent. And return rates varied primarily by product category. So that's historical, and then look what happened. Browse to purchase time windows expanded from minutes to days. Why? You're online, you don't care. If you're staying in a store, you're already there. Return rates doubled. Correlation between browsing time and purchase intent weakened. Nordstrom noticed their models were overstocking stores and understocking distribution centers. That's a double kiss of death because the behavior data changed. So they put in new monitoring system, changed the experience, and cleaned that up. That's good work. Farmers, well, boy, they ran into weather too, housing developments. Their claims were their expected values for different event types, seasonal patterns of weather, naturally, property values. Construction materials, as you know, have skyrocketed in cost. So farmers took this and they recognized they had extreme weather events. This is just a real problem. That's why all the insurance companies are pulling out of Florida, California, and Texas, by the way. New construction material. Now, this is really cool. They're trying to touch on 3D printing houses here. That's turned out to be a real problem. Contractors are objecting to this. They'd rather use their supply chains of lumber. But property values have increased faster than the models anticipated these high-risk areas. So their loss predictions inaccurate, means they're losing a bunch of money, and they underestimated frequency and severity of claims, and then they fooled around with, they monitored drift, and what happens if this just doesn't work out? You pull out of the market, just leave the market. California's going through that, what Florida went through. Florida's down. By the way, if every insurance company pulls out and you're a homeowner, what's left? Well, you could move, absolutely, but if there are no insurance companies or just one or two where you have a functional monopoly, how do you sell your house? How wealthy do you guys have to be to fly naked in that market? To have a house with no insurance. If you have a mortgage, you have to have insurance. If you don't have a mortgage, if you choose, if you're a billionaire and you lose a $50 million house, okay, we rebuild it. What's everybody else do? I'm not kidding. H&R Block naturally had their prediction drift. Notice if you get a new law that comes in, it's going to impact what you do if it applies to you. So this model, expected tax returns based on inputs, stable performance, but average predicted refund began increasing. Normally distributed to right skewed over to higher income levels, and the confidentials got bad. And they got wide, which is not good. Now, the tax code change altered the relationship between inputs and outputs. It's concept drift. So they identified their prediction drift when they compared one tax season to the next. Very interesting. They changed their features. Now, power outages, again, I'm not going to hit this because it goes right back to the weather. So maybe we should all start paying a little more attention to the climate change that we're dealing with. Now, automobile insurance, whatever's going on in the housing market goes on in the auto market. Okay, a hurricane comes through, cars are underwater, just like homes. So notice what they were looking at. Predicted risk levels gradually shifted toward higher risk. Notice if you have an old car, you don't have as many sensors in the bumpers. If you have a really old car, you don't have any sensors at all. Today, if you just get into a fender bender and you got to replace the bumpers on both cars, nobody's hurt, just a bump. Okay, it's thousands of dollars because all those sensors are in both bumpers. So that's what they're talking about. Increasing variance among similar customer profiles, and they had outlier premium recommendations at both extremes based on your risk. Okay, even though customer input data remained consistent, the drift was changed by how their ensemble models weighted different factors over time. So what they have to do, look to see what it was doing, and it was becoming more conservative in risk assessments. Well, if it becomes more conservative in risk assessments, what does that mean for your policy premiums? Up or down? They go up. Okay, Nielsen got into it. They had environmental changes in their television viewership models with streaming services and changing consumption patterns. Nielsen TV's been around for a long time, prior to the streaming system. Notice their system was designed with cable and broadcast. Households watch content primarily on television sets. Programming followed consistent release schedules. It's the Wild Wild West out there now. So they had to somehow capture this. Multiple devices, binge watching, okay? Then algorithm and content recommendations change discovery patterns. You guys can find anything you want, especially if you're subscribing to not only the networks, but the cable channels. Notice what they had to do. Their models were sound. Their precision, recall, and accuracy were great, except for one thing. It's not what we were doing. Actual viewing behavior. Most of the boomers would like to have ABC, NBC, and CBS, and that's it. And we'd like to just be able to turn the dial with our hands. Okay? You guys have changed everything. Terrible. Notice they got data drift because they were looking for the wrong things. They were measuring the wrong things. And so they ended up having to put in all these, they put in a brand new system, actually. I was going to say new feature. They just came in with a new system. Toyota ran into it when trade policy shifted. You can see how all this just keeps coming. By the way, this is all conventional AI. That's all this stuff is. They had supply chain optimization problems when global trade policy changed, tariff structures. Notice they developed their models when it was stable, the supplier networks were optimized, and they had consistent international shipping and logistics. The good news is, up to date, we still do, except for what spot? What's the big danger in consistency in international shipping? Where's the trouble spot? The Houthi rebels in Yemen are being supplied with pretty interesting drones, and so we have to put different routes. You have two choices. You can go all the way around Africa, because you can go way out to sea to avoid the Houthis. If you want to use the Suez Canal, you're going to have protection in there. Somebody's going to have to shoot those drones down. So that's been a problem. Straight geopolitics. So the new trade policies altered that environment. Quick tariff implementations, supplier relationships got skewed. and then regional manufacturing from supply chain restructuring. By the way, if a boat has to go all the way around Africa, it costs a whole lot more money. Okay, so what they did, everything was going correctly. They had the same optimal recommendations, but it was not, had anything to do with business routing. If you're starting to get your technical people tell you, everything we're running looks great, accuracy, precision, recall, but it makes no sense to what's going on in your reality, you're the doctor. Okay, so we had great models, gave wrong business, I love it, inappropriate business recommendations. That word better should be wrong. Okay, so you had disconnect between the outputs and realities. So what'd you have to do? New system. By the way, who do you hire when I want to incorporate geopolitical risk factors in policy sensitivity analyses? Somebody that majored in political science and had enough sense to understand what's going on. Hotel recommendation. This is great. Just tell me right now, forget all this stuff. What blew up their hotel recommendation engine? Airbnb. Sure, the rental markets. And what happened was their model was developed with nice traditional hotels, standardized rating system, captured quality differences, TripAdvisor and so forth. Location and amenities were decision factors. That's the good old standard stuff. Short-term rental revolution blew it up. Different evaluation criteria, authentic experiences became competitive with luxuries. Well, that's kind of gushy. Price to value shifted dramatically. You can shop Airbnb and get a whole lot of range. By the way, what's the kiss of death when you rent a hotel room for the hotel? What do they hate the most? Did you go through Expedia? Guys, if you rent a hotel room and you go to Expedia or any of the other, what we call aggregators, where's the hotel going to put you? Right next to the elevators. So all day long, ding, ding, ding. Have you ever had a hotel thank you for going directly through their own website? They will. You'll get a whole lot better room. I just mentioned that because of this. Okay, so what they had to do, their marketplace change just went away. So it's technically accurate, irrelevant though. So the technical people are irrelevant. Not really, their models are. And so their business analysts picked it up, which is great. I wonder how fast, okay? They looked at search patterns, user engagements, and so they completely redesigned the system. That's really cool. So what we're going to do on Wednesday, I'm going to touch on maintenance. I went through monitoring a lot more because I want y'all to understand that was monitoring and maintenance. And so there's a couple things here I want to touch on. We're going to get into generative AI on Wednesday. The kicker with that is you guys know what traditional AI is. You know what conventional AI is. Not many of your contemporaries do. To them, generative AI is AI. So just keep that in mind as we go ahead. Okay? See you Wednesday.